What's up, everybody? Welcome back to the channel. Today we're going to be doing another Python tutorial. We're going to be looking at Beeswarm plots, and Beeswarm plots are actually one of my favorite plots. They're basically just a one-dimensional scatter plot. They let us see distributions and they let us see, a couple different metrics about the data set. And as well, they're really cool when they're used with things such as violin plots or box plots, and that really emphasize the distribution. So we're just going to be doing that. We'll be making a single Beeswarm plot first, and then we'll jump into a grid. But anyways, let's jump into it and we'll get started. All right, so let's start off this tutorial. We're going to be in Jupyter Notebook like always, because Jupyter Notebook is GOAT. And if you're not using Jupyter Notebook, just kidding, you can use whatever, but I like using Jupyter Notebook. It just makes it a lot easier to kind of do line by line and code by code snippet. So it makes it a little bit easier to do this kind of stuff, in my opinion, but you can use whatever you want. You can follow along. This will work if you're using like PyCharm, or if you're using Spider or Visual Studio. No matter what you're using, it's all going to work. What we're going to do is we're going to first import our packages. And the nice thing about making these is we actually only need 2-3 packages that we're going to use. So we're going to say pandas. So we're going to import pandas as PD. This is going to allow us to manipulate our data. And then we're going to import matplotlib.pyplot as PLT. And then as well, I like to import matplotlib as MPL, just the whole package and library of MPL. And then the one that's actually going to help us create the actual Beeswarm plot is called Seaborn. Now, if you don't know what Seaborn is, it's a package, it's a library that helps us to make really cool visualizations such as heat maps and these Beeswarm plots. You make box plots, violin plots super easily. So what we're going to do is we're going to import Seaborn as SNS. And this should just come pre-installed when you download Python for the first time. If you don't have it, like if you get an error, so we'll run this, and if you get an error, then you need to pip install using your terminal or command line. So look up how to do that, look up how to import Seaborn, and kind of get started there. And then after that, so we have our libraries installed, and it's pretty cool because that's all we need for this one. Normally when I've done these tutorials in the past, we've needed like 6 or 7 or sometimes like 10 of them. So what we're going to do is we're just going to import the data. So we'll just say import data as a comment, and then we're going to call it df. So this is our data frame, and we're going to read in the CSV. So the CSV we're going to be reading in is called Beeswarm tutorial, tutorial.csv. So we'll read in the CSV, we run that, and then what we're going to do, we can just take a look at the data frame just so we kind of have an idea of what's going on in here. And what this has is it has our player, position, squad, how many 90s they've played, and their progressive passes for the season. This is Premier League and progressive passes in the season. This is all from FBref and StatsBomb, so be sure to go check them out as well. They provide some great free data. And now what we're going to do is, now that we have the data, as you can tell, it's a CSV. It looks just like an Excel file if you're familiar with Excel. And what we're going to do is we're just going to create, so what we're going to want to do with the Beeswarm plot is we're going to want to create a way to measure a player and where they rank amongst other players in the Premier League in terms of their progressive passes per 90 minutes, essentially. So we have 90s right here, so it makes it super easy for us to just create another column. So that's what we're going to do. We're going to make a column called progressive 90, or we'll call it per 90 just for this case, so we know what we're talking about. So we're going to say df, then we're going to say per 90. So this is creating another column, essentially, if we set it equal to something, and we can say df progressive, and then df 90s, like that. So what this is going to do is it's going to take this data frame per 90 that's not created, and it's going to create it. And then that's going to be equal to, for each row, it's just going to take the progressive passes that they have, and it's going to divide it by 90s. And it's going to give us, essentially, on each row, how many progressive passes that player has per 90 minutes, which is really nice. It's a really quick way to do it. and calculate it. FBref makes it kind of set up pretty easily to do that. And so we'll run that, and then we can look at the data frame again just so that we know what's going on. So if we do df.head, we'll look at the top 10 rows, and now we can see, okay, now we have this per 90, and this per 90 right here is exactly what I was talking about. It's just the progressive. 76 divided by 11.7 is 6.495, whatever. And it does that for all of them. And our data frame right now is sorted. It's sorted by player, just last name. So here's the A's, and then it goes down. It'll have B's and C's, whatever. And so what we're going to want to do now is we need to do a little bit of data manipulation, because we obviously don't want to compare a player to every single player, because obviously there's different positions. Players have played less minutes than other players. So for example, Sergio Aguero right here, he is at only 1.6 90s and 1 progressive pass. So he's pretty low right here. I mean, Adrian has 0. So if we compare like Adrian to this Tosin, I can't even say his last name, from Fulham, but he's played a lot more and he has 36. So he has 2, and he's going to look way, way, way better if we compare him to Adrian. So what we want to do is we want to manipulate our data frame so that we can kind of eliminate those players that we don't want to compare against. So what we're going to do is we're just going to set our data frame equal to, and then we're going to have to do this thing where basically we're going to filter the data frame. And we're going to filter the data frame so that it's only for players who have played more than 6.5 90s, as well as we're going to get rid of goalkeepers. So we don't want to compare goalkeepers to anybody, because goalkeepers and progressive passes, usually goalkeepers are going to have 0 unless they're like some keeper that's just blasting long balls all day and somehow accurate with his passes. But so what we're going to do to filter this, we just need to call data frame, set that equal to, and then we'll say df, and then these brackets, and then we need to do df again, another set of brackets, and this is where we're going to put our 90s column in a string. So you put quotations and then 90s. And then on the outside of the inner brackets, we're going to do is greater than 6.5. And so we can do greater than or equal to. We'll do greater than or equal to. And so what this is going to do is it's going to filter each row, and it's going to go down each row, and it's going to say, okay, if this is greater than 6.5 90s, then we'll keep it. If not, then we will get rid of it. So I'll show you what it does. So we'll run that, and then we'll just look at the top 10 again, and it should have gotten rid of, say, Adrian. It should have gotten rid of Aguero. It should have gotten rid of Nathan Ake. Anyways, we run that, and now we can see, yep, it did exactly what we wanted it to do, which is perfect. And then the next thing that we need to do is we want to get rid of goalkeepers. So it looks like it got rid of Adrian, so we won't actually know. Or I guess we could look at the whole data frame and see, but we're basically just going to do the same thing for goalkeepers, and we're just going to say df equals df, and then on brackets, inside df brackets, and then we're going to call the position column. And then to get rid of goalkeepers, essentially we're just going to do a not equal to. So you do this by an exclamation mark and then equal to. And then in strings, we're just going to put GK, which is goalkeeper. And what this is going to do, just like before, it's going to go down the position column, and it's going to look at each row, and it's only going to grab and put it into the next data frame. It's only going to filter that into the data frame if the position value is not equal to goalkeeper. So all of these should stay, and then it'll just get rid of all the goalkeepers basically. And then another trick that we need to do is, as you can tell, over here is called our index. These are our index numbers. And this is the index number from the original data frame, and we want new index numbers so that it's basically its own data frame, essentially. So what we're going to do to get rid of this index is we are going to just say .reset_index and then parentheses. So this is just going to make it so it's 0, 1, 2, 3, 4, 5. It's basically just going to put it starting from 0 and just count up until the rows. So we'll do that, and then we'll look at it again, and we'll do the top 25 just so we can verify that there are no goalkeepers. And yep, so we can see index right here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we're just verifying that there are no goalkeepers, which it looks like there isn't, which is good. And then what we're going to do now is we're just actually going to create the actual Beeswarm plot. Now that we've manipulated our data to the point where it is sufficiently clean as to where we can kind of do the analysis. So what we're going to do is we just need to create a figure. I'm going to run a couple of cells just so we can kind of see everything. And what we're going to do is we're going to say fig, ax equals plt.subplots. And then we're going to set our fig size equal to about 10 and 5. So this code, what it's doing, it's creating our original figure and axis. And then as well, I didn't do this before, but what I usually like to do is I like to create just like generic colors. So I'm going to create a background variable so I don't have to keep calling like the hex code. And we're going to set that equal to a hex code. And this is one that I've just been kind of using recently, but you can use this one or you can try a different color if you want to do like hot pink. I don't really know where that would look good, but maybe you want to use it. So we're going to set our background equal to that hex code. It's kind of like a smoky gray. And then we're going to create another variable called text color. And we're going to set that equal to just white. The next thing that we need to do is we just need to set up our swarm plot. And it's actually super simple with Seaborn, like I mentioned. If we just say sns.swarmplot, and then it takes a couple of values. It takes an X, and then it takes a data, and then it takes a color, essentially. Those are the only, really you only need your X and your data. So we're going to say X is equal to, and this is the column that you're wanting to do. So like I said, we're wanting to evaluate per 90s. So if you're wanting to evaluate just progressive passes and not per 90, you could use the progressive. You could do PROG. So what we're going to do is we're just going to say per 90 in string, and then you need to pass in a data argument as well. So comma data equals, and then you need to pass in the name of your data frame. So that we called it df right here. So what we're going to do is we're just say data equals df, and we'll just run this just so we can kind of see what it looks like. And there you go. It's really that simple. This obviously doesn't look as good, but it kind of conveys the same message. Really, from here on out, it's just aesthetics. But what we're going to do now is we are going to I'll show you how we can kind of clean it up a little bit, and then how we can compare two players. So what we're going to do to clean it up is we're going to set the background color to not be this white. We want it to be black just because it's easier on the eyes. So we're going to set up the base layer. So we'll just say set up base layer. And this is where we need but actually I want to do this underneath the fig. So we're going to set up base layer, and what we do here is we just say mpl.rc params, and then in brackets we're going to call an xtick.color, and we're going to set that equal to that text color that we created before. So we'll just do text color, and then we're going to do mpl.rc params.ytick, or in string ytick.color, and we'll set this equal to text underscore color. And so what this is going to do is it's just going to make the ticks white for us, because now what we're going to do is underneath our fig and our AX, we're going to say fig.set underscore face color. And then in parentheses, we'll pass in our background. And so this is why I made it. This is why I made the variables. So you don't have to type in the hex code. Obviously our text color is just white. It'd be easy to type in white. But if you're working with hex codes, you don't want to have to be looking up hex codes every 5 seconds. So we'll just use the background variable. And then the other thing we're going to do is just say ax.patch.set_face color and do background again. So now if we look at it, now we have a black background, and sometimes you have to run it twice for some reason, but now our tick marks are set to be white instead. So they were black, I had to run it again, now they're white. And so that really is how we do that. And to get rid, I don't really like the box around this right here. So what we're going to do here is we are going to do something called spines, and we're going to get rid of the spines these are called the spines. We're going to get rid of them. So we're going to do this just under this is part of our setting up our base layer, and we're going to create a list. We're just going to say spines equals, and then inside of the list, we're going to say top, bottom, left, and right. So that's our spines, and then all we need to do to get rid of these spines, we just need to say for x in spines, and then we'll say if x in spines. Oops, I accidentally ran it, did not mean to run it, but anyways, we'll still keep going. And then we'll do ax.spines, and then in parentheses or brackets, do x, and then do dot set underscore. I keep clicking the wrong button. Set underscore visible, and then in parentheses, we're just going to pass false. So now let's look at it. So that's kind of the code that I use to get rid of these spines. I think it looks a lot better, so we don't have like a weird random box on the edge of it. And then the next thing we can do is, so now that we have our seaborn, like our swarm plot set up, you obviously can change the color. So we'll just say color equals white. So now that they're white dots instead of blue dots, you can set any color you want. And there's a lot of other things you can pass in here, but for really what we're doing, that's all you need. And then, so now what we can do is we can compare a couple of players. So the easiest way to do this is just by creating a scatter on top of it. So we'll just do plt.scatter. And this is a manual way. This is not like the automated way, which obviously when you're creating these and like you're wanting just to automate stuff, you don't want to be doing it by hand every single time, but this kind of gets a basic idea of what you're looking at. So what we want to do is let's compare, let's see, we have Tiago right here. So we'll throw in Tiago. We'll just do plot Tiago on this. Tiago. So what we need to do now is we need to pass in an X, a Y, and then we're going to pass in a color, and as well, we're going to pass in a size. So we're going to make it a little bit bigger. So this isn't actually going to plot the exact dot, but it's going to plot where Tiago is on the map. So what we're going to do is we're going to say X equals, and we need to come find Tiago here, and we can see that Tiago is 9.8 per 90. So we'll copy that, and we can pass that in right there. And then your Y, this axis right here is just all 0. So you just need to pass in 0. And then our color, let's do, since Liverpool are red, let's do red. And then our size, we'll just do like 200. It makes it a little bit easier. And boom, so we can see that he's actually number 1 on the list, which I did not know. I don't think he's played, he hasn't played, let's see, where was he at? Yeah, he's only played 8.3, so maybe if you wanted to exclude like less than 10, it depends on when the season is and where it's kind of at. But either way, this kind of shows that Tiago's good. And so what you can see now is it has the white dot is in front of the red dot. We'd rather have the red dot on the top. So what we're going to do is we're going to use something called Z order. And what Z order does is it sets the order of the elements in the plot of like layered. So which one's on top, which one's on bottom. So what we're going to do is we're going to go back to the swarm plot, and we're going to say z order equals 1. And then on the scatter, we'll say z order equals 2. And we can run that. And now Tiago is on top. And that really is all there is to it. You can plot as many people as you want, as well as you can plot, as many different things as you want on this. You can plot like annotations, give it a good title. I'd recommend working with the X label so it has a good X label. So this is how we create just one swarm plot. I thought it would be more beneficial to go over just one so that when we get into doing the more advanced ones, it's a little bit more understandable of what's going on. What we're going to do now is we're going to create a grid of these swarm plots, and it actually is a lot more complicated and it's a lot more in depth. So I'm probably not going to make it as beginner friendly, but you can definitely still copy the code and kind of follow along if you want. But I do recommend that you understand, that you kind of go and understand like the basics of coding, especially for loops and manipulating data with pandas, because that's what we're going to be doing here when we create these kind of grid style ones. So jumping into the grid style ones, we need to read in our next CSV. So this CSV file that we're going to read in actually is a little bit different. It's going to have more metrics, and this one I have called df2 is what we will call it. And then the file, so we'll do pd.read_csv, and the file is just called beeswarm2.csv. So we'll look at that and we'll see how that kind of compares to the first one. Say df2, and now what we can see is that it's basically the same thing, but it's giving us our completions, our completion percentage, progressive distance, assists, expected assists, key passes into the final third, into the penalty area, crosses into the penalty area, and progressive passes. So really this data frame gives us a lot more information, and it's going to be a lot more beneficial for comparing how a player ranks in different metrics and not just, one metric. So we're going to do the same thing that we did before. We are going to do some data cleaning, the funnest stuff that you can do in the history of mankind, probably. So first what we're going to do is, so we can kind of plot and automate stuff later, we are going to split this player name. This is the one thing I do not like about FBref data when you convert it to a CSV, is it gives you two names. So what we're going to do is we're just going to use a code snippet to split the player names. We're going to say split player names. And we do this by just saying df2, and we're going to call the actual player column. So we're going to say df2 player, and we're going to set that equal to df2 player. And then we need to use the string split method. So we're going to say .str.split, and then we want to split it. As you can see, it has this backslash. So in Python, to indicate a backslash, we actually need 2 right here. And then we want to use an argument, so comma, and then use another one called expand. Set that equal to true, and then we need to put brackets 0. So what this is doing is it's just splitting the player names. It's going to split each player name into like a string list, and then it at each backslash, and then we just want the first one. So in Python, obviously index starts at 0, so we just want the first one. So we're just going to put 0. And then the next thing that we need to do is we want to filter out our goalkeepers, and then greater than 6.5. So we can actually just go back. I'll just type it actually. It'll do it for the memories, I guess. So we'll say df2 equals df2, df2, and then we're going to say position does not equal goalkeeper, and then we're going to say df2 equals df2, df2, and then we need to do 90s is greater than or equal to 6.5. So, and then as well on this one, I'm going to reset the index so we can use some nice for loops later. So we'll do that, and we can take a look real quick at what our data frame is kind of looking like so far. So as you can see, we split the player, and as well, everything else is looking good. So, we also filtered for the goalkeepers and people who had played more than 6.5 90s. So everything's good there. The last thing we want to do is we want to do what we did before, and we want to create the per 90 stats. And we do this obviously just with creating another column. So we're going to say df2, and I don't want to type this all out, so I am going to just copy and paste and then just kind of edit where I need to. So we're going to say df2 progressive equals df2 progressive divided by df2 and 90s. So we need to do this for what we're going to do is we're going to compare progressive passes, passes into the final third, expected assists, key passes, as well as passes into the penalty area, and then as well completion percentage. So we don't need to divide completion percentage because that doesn't really tell us anything. If we divide it by 90, if we divided 81.3, we'd get like a 0.09 completion percentage. That makes no sense. So we're only going to divide the other 5. So you can just copy and paste down 5, and we'll just edit the columns. So the first one is going to be progressive, and then after that, we're going to do passes into the final third. And you need to make sure that you're spelling everything correctly. And then the next one is going to be expected assists. So these are just all the column names that we're manipulating right here. So XA, XA, and then key passes was KP. And then penalty passes into the penalty area is PPA. So this is what it should look like right here. I would recommend that you make sure you get this right because it'll be really important. Otherwise, your data is going to be skewed and it's going to look a little funky. So we'll run that, and then we can look as well. We can say df2.head, kind of just look at it and see what it looks like now. So this is our data frame. And basically what it's done is it's taken those data frames. We didn't create a new data frame this time. We just essentially fixed the data frame, if that makes sense. So we went from key passes having up here 11 to now Patrick Van Aanholt is 0.94 per 90. Okay, so now that we know and we have actually done all of our data cleansing and kind of know what our new data frame is going to look like, so now we can actually start creating the Beeswarm grid and having a couple different metrics. So like I said before, we're going to be looking at progressive passes. We're also going to be looking at passes in the final third, expected assists, completion percentage, key passes, and as well passes into the penalty area. So what we want to do first, and this will make more sense as we kind of get down the road and kind of get further into it, but we're going to want to make a list of the metrics. So a list of the columns. So what we're going to do is we're just going to create a list of metrics we want to use. And we're going to be creating a 3x2 grid. So we need 6 metrics. So we'll just call this metrics, and we'll set this equal to. And so we're going to look at first, we're going to look at progressive passes, and then we're going to do passes in the final third, and then we'll do expected assists. Next we'll do CMP. We need to make sure that everything is spelled exactly how it is in the column name. And then after that we'll do key passes, and then finally we'll do passes into the penalty area. So we need to just make sure that we have a list of our column names that we're wanting to use, and we'll just run that. And now we can actually go ahead and start. I'm going to run some more cells. So now we can actually go ahead and start creating our actual grid. So what we're going to do is we're going to say fig, axes, AXES, equals plt.subplots. And then here we're going to specify how many rows and then how many columns. So we want 3 rows, 2 columns. And then we'll set our total figure size equal to 14 by 10. That kind of is the one that I've used. Its actual plot's a little bit wider, so they're not just like squares. But we can run that, and now you can see this is what it looks like. So as I said, they're a little bit wider. They're not just like a square. And as well, so this is just our grid. These are our plots. So what we're going to do now is we're going to set up our base layer like we did before, and then we're going to run a for loop. So basically we're just going to loop over each one of these plots. These are called axes essentially, or subplots if you want to call them that. We're just going to loop over each one, and we're going to plot on each one our different metric that we're evaluating. So first we'll just set up our base layer. We'll do this by saying fig.set underscore face color, and then we'll pass in our background argument. And then as well, like we did before, we'll do ax.patch.set underscore face color and pass in our background variable. Sorry, they're not arguments, they're variables. And we do that, and so now you can see our figure and our axes are both our background color. So what we're going to want to do now is we're going to want to set up our tick colors to make sure that those are the right thing. This is the final thing we'll do for our base layer. So we'll do npl.rc params and then xtick.color equals text underscore color, and then npl.rc params, then we'll do ytick.color is equal to our text color. So it might not look like anything, but it's changing. If you ever wanted to plot stuff on the outside, it's going to change all of the tick colors essentially to be white. So that's not really anything that you necessarily need to do. I just like to do it on every graph that I create if it has ticks. So now what we're going to do is we are going to create a big old for loop. And this is where the code kind of gets a little more complicated, because we're going to be creating a for loop, and then we're going to create a couple of for loops and if statements inside of that for loop. So it gets a little crazy, but if you follow along, it should work out perfectly. So what we're going to do is we're going to create our initial for loop, create initial for loop. And by doing this, we're going to say for I, comma, ax in zip. And then we're going to just use a column for that we're going to loop over essentially. And we're going to say df2 player. And then we'll do axes.flatten. So what this is doing, zip, in 100% honesty, I don't know exactly what it does. I do know that you need to do it when you're looping over subplots. So maybe if somebody knows exactly what it does, you can leave a description of it in the comments. But then we're going to use this. We have to use axes.flatten as well, because this axes up here, our subplots, actually it's like a two-dimensional array, and we need it to be one-dimensional to loop over it. So axes.flatten is just flattening this array up here, axes, so it's not two-dimensional and it's one-dimensional, which kind of doesn't make sense. And if you don't really want to get into that, you can just ignore exactly what I've said for the past couple seconds. And then what we're going to do, so we're creating this for loop, and what we want to do is we want to set the background color of each one of these to be our background. So we do this by just saying ax.set underscore face color, and then we pass in our background variable. So I mean, we can just run this right now and you'll see it sets the face color of exactly what we want. So it's looking good so far. And then what we want to do is we want to create we want to get rid of the spines on all of them. So we're just going to say spines equals, and this is what we did before. We just create a list of top, bottom, left. Obviously, you can just go up and copy and paste this if you want, but I'm just typing it again just to kind of emphasize what it's doing. And then we say for x and spines. So this is looping over this spines list. And it's going to say if x in spines. So it's going to look for each one of these. It's going to go over each one of these and say if x is equal to spines, then we are going to do ax.spines, and we are going to pass in x, and then we're going to say set underscore visible and pass in false into that. So now we can run that again, and as you can see, no more ugly box looking thing around each one of our plots. So what we're going to need to do is we need to create a couple of counters to be able to loop over this correctly. There might be a more intuitive way to do this, but this is just the way that I found worked. So we're going to create 3 counters. We're going to say counter equals 0, and then we're going to say counter 2 equals 0. Make sure you're doing this out of your for loop as well. Don't do this inside of the for loop. Do it just either below your RC params or do it like below your fig axes. Don't do this in the for loop or else it's not going to work. And then we're going to create another one called met counter and set that equal to 0. So what this is doing is we're going to use these counters to count. One, the counter here, counter and counter 2 are going to help us count through here, so we're plotting on the correct axes. And then our met counter is going to help us so that we are counting over the metrics list and plotting the correct metrics. So we'll go back inside of our for loop and make sure your indentation is correct. It should be 1 tab or 4 spaces from where your for loop started. So just make sure everything lines up or else it'll give you like an indentation error, which is the absolute worst. So now what we're going to do, so we're going to start and we're going to say sns.swarmplot. So we're plotting a swarm plot again. We're going to say x equals, and this is where we're going to pass in our metrics list. We're going to say metrics, and then we want to pass in our met underscore counter. So what it's doing is going to say x equals our metrics at our met counter. So our met counter is at 0 right now, so it's going to plot progressive first. And then what we're going to do later is we're going to add 1 at the end of this for loop to our met counter. So the next time it runs the for loop, it's going to be at 1. So it'll plot 1/3. And I'll kind of show you exactly what it's doing here in a sec. But essentially what we're going to do is we're going to say met counter, then we need to pass in data again. So we're going to say data equals df2 like we did before. And then this is where it gets a little bit confusing with the axes. So we're going to say AX. We need to pass in to the swarm plot which axes we're going to be plotting on. And so we're going to say AX equals axes. And then we're going to do counter, comma, counter 2. And then we can set the Z order again like we did before to 1. So right now our counter and our counter 2 are at 0 and 0. So this one right here, this top left plot is 0, 0 technically. And then if we move one right, it's 0, 1. This one's 1, 0. This one's 1, 1. Then this one's 2, 0. And this one's 2, 2. 2, 1. So that's kind of, we'll plot this. Actually, it won't work. It'll give us an error if we plot it right now because we haven't done everything. And then the next thing that we're going to do is we can just set the labels on each of them. So we'll do ax.set underscore x label. And then this needs to be in parentheses. And we want to pass it something in called an F string. So we're going to say F and then 2 quotation marks. And on the inside of this, we need to put in these curly brackets. And we're going to pass in our metrics, met underscore counter like we did before. So it's going to label it with whatever this is in our loop. And then as well, you can set you can do a comma after the parenthesis and do C equals white if you want, or actually because I've been preaching about it, we'll do text color. So I can use them efficiently, I guess, so I'm not a hypocrite. Okay. So that is all we need to do for the swarm plot. And now what we're going to do is we're going to create a counter. Essentially, we're going to add up these counters. So what this is going to do is we're just going to say at the end of each for loop, we want to do met underscore counter plus equals 1. So what this is going to do at the end of each for loop, it's going to turn this met counter. At the end of the first one, this will now be 1 instead of 0, and then it'll loop over again, but it'll do it for this position right here because our met counter is at 1 and not at 0. Met counter isn't anything specific, it's just metrics counter. I didn't want to write out metrics though. So it's just a variable I've made up. And then the next thing we need to do is, this is where it kind of gets, I keep saying this, but this is a little bit confusing just with the math and kind of the concepts behind it. So we'll say if counter 2 is equal to 0. So we want to do an if statement now to kind of determine what we want our counter and counter 2 to be at. So we're going to say if counter 2 is equal to 0, then hit enter. Make sure your indentation's correct right here. And we're going to say counter 2 is equal to 1. And then what we're going to do is we are going to just say underneath that we need to pass something called continue. So what continue, I'll just finish this and then I'll explain what continue kind of does. And then we want to create another if statement, and we're going to say if counter 2 is equal to 1, then we want to say that we need to put a colon and then hit enter, and then we'll say counter 2 now equals, sorry, I just realized I put double equals. This should only be one equal sign. And so we're going to say counter 2 is equal to 0, and then we want to do counter plus equal 1. So essentially what this code is doing, we can kind of go over it now. I'm actually going to run this and it'll make a little bit more sense, and I have an error. Oh, you don't need that. So as we can see right here, these are the swarm plots that we've just created of everything that we've done. And so essentially what this is doing, kind of this right here. So our met counter is just doing plus equals 1 at the end of every for loop. And what this is doing is it's allowing us to go from metric to metric. So we start with progressive passes, then we went to 1/3, then we went to expected assists, then we went to completion percentages, then we went to key passes, and then we went to passes into the penalty area. And that just allows us to loop over our metrics list correctly, one by one. The next thing that happens is we have this if counter 2 is equal to 0. So we want to say if our counter 2 is equal to 0, so right here it's 0, 0, right? So counter 2 is our second one. So if this is equal to 0, so if our counter 2 is equal to 0, then we want to put it into it equals 1. So we're going to say, I'll type it out. So so in the first one, counter 2 is equal to 0. And this is kind of what our axis looks like. It looks like this. It's 0, 0. And then what we're doing is we're saying counter 2 is equal to 1. So it's going to say counter 2 equals 1. And our axis now is going to become 0, 1. So it's going to move over to the right one. And then we use continue because we don't want to do this right here. We don't want to, because if we didn't do continue, so what continue is doing is it's going to essentially break out of the current iteration of the for loop, and it's just going to go back to the top. It's not going to do anything that's below. So what it's going to do now, if we didn't have continue, then it would just keep going, and it would say, okay, so we created counter 2 is equal to 1, and then it's going to say if counter 2 is equal to 1, then it's just going to put it right back at 0, which is not what we wanted. So we want to keep it at 1, so that's why we use continue. So it doesn't do this if statement right here. And then since now counter 2 is equal to 1, it's going to say, okay, counter 2 is equal to 1, and so we want to say if counter 2 is equal to 1 on the next time that we run through it, because the next time that it'll run through, it'll say if counter 2 is equal to 0, and it's not, so it'll go down to this if statement right here, and it'll say counter 2 is equal to 1. Okay, we want to set counter 2 equal to 0, but we want to add 1 to our original counter. So it'll say counter 2 equals 0 and counter equals, it'll add 1. So it was 0, so now it's going to be 1. So now here's what our current axis is looking like. It'll be 1, 0, which is this one right here. So it starts at 0, then it goes 1, then it goes 2, then this is just 0, 1, 0. So essentially what this is doing is it's going to add 1 onto these, but it will only add 1 to these once it's gone back, once it's done both of these, essentially. So if we didn't do this, then it would only plot this one, and then it would like just go down this row over here, and it wouldn't ever go over here, and then as well, we wouldn't be plotting the different metrics. So hopefully that made a little bit of sense. If it didn't, I would just recommend kind of messing around. You can mess around with this right here and kind of see exactly what it's doing. It makes a little bit more sense if you kind of can mess around with it and see, okay, if I change this from, if I get rid of this continue, what happens, you know? So that is how we set up our original kind of, you know, our original grid. So now we'll just kind of compare players, and to compare players, it's a little bit simpler. So we're just going to create another for loop inside of our original for loop. And to find out player names, we're just going to do df2.players. Actually, it needs to be a capital P because we're looking at our comments. .players.unique. And so now we get a list of all the unique player names. So we can copy these and we can kind of compare different players. I'm just going to be showing how to do one player, but it's essentially the same thing if you want to do multiple players. So what we're going to do is we're going to create a for loop in here, and it needs to be on the inside of our for loop with the correct indentation. And we're going to say for x in range, length, df2 player, like that. So we're creating a for loop, and we're going to go over the length of the data frame to column player, and then colon, and then hit enter. And we're going to say if df2, and we can do player, and then x is equal to, so double equal sign, and then we'll compare, let's see, where's that list? Let's look at Jack Grealish. I like Jack Grealish. I like his low socks. I think that's pretty cool. And he's good. So we'll say if df2 player x is equal to Jack Grealish. So you need to make sure that you're typing this in exactly how it is down here. That's why I like using just copy and paste so that we don't get any sort of errors when it comes to, you know, how it's spelled or accents on the name or anything. And then we are just going to say ax.scatter. And then we'll say x is equal to df2. And then in here, we're going to pass in metrics, met underscore counter. And then on the outside of that, we need to pass in another bracket of x. And then we want to say y equals 0. And then we can do our s equal to 200 like we did before. And then I don't know exactly the hex code for Aston Villa. I don't know how you say it. I say Villa because I used to live in Argentina, so that's how I kind of pronounce double L's. And then we'll just say C is equal to white. And then we can do our Z order like we did before. We'll set that equal to 2. So this should actually plot Jack Grealish every single time on each one of these. So now look at this. It's running, and there we go. There's Jack Grealish, actually one of the best players in the Premier League right now. So as we can see, that is how we would do it to plot a player on each one of these. So each one of these is where Jack Grealish would show up. Obviously, those aren't his exact dots, but that's where he is located on the thing. So this is kind of how you do it. If you wanted to compare him to a different player, you just do inside of this, you could say if df2, actually we're just going to copy this so we don't have to type everything again. We'll say if df2 is equal to, and then you just need to change the name. So let's compare him to, I don't know, who should we compare him to? I don't watch the Premier League too much. I just know the big names. I don't know the younger names. Or we could do Jaime Rodriguez. James, R. So this is in alphabetical order if you're having trouble finding people. Okay, here we go. Here's Jaime. So we'll copy and paste that. I didn't copy the J, but we will type that in. So you need to copy and paste it because as you can see, the Rodriguez in the file has an accent on the I. Make sure it has a capital J. And he is Everton, so he's this blue color. We'll just do, just for purposes, we'll do red. And we can do red. So here is how Jack Grealish and Jaime Rodriguez compare on the metrics this year. So as we can tell, progressive passes, Rodriguez is doing a little bit better. Expected assists per 90, it's definitely Jack Grealish, as well as key passes in the penalty area. They're about the same on completion percentage. Then into the final third, Jaime Rodriguez is doing a lot better. So that's kind of how you just set that all up. And that's kind of the basics, honestly. If you wanted to, you could add a plot, title. You could kind of mess around and do, down here, you could add like the name of each one of them. I don't usually like to add more information on the thing than necessary. I just feel like if we're adding a bunch of text and everything, it makes it look a little clunky. So if you are going to add any sort of text that describes what is being compared, I recommend just adding some text down below or up in the title. And that is the basics of that. So obviously a little bit more complicated, a little bit longer of a tutorial, but hopefully you can watch this, and if you didn't grasp a concept, you can go back and watch it, as well as be sure if you want, you can reach out to me on Twitter. I'm happy to help and try and help with any sort of errors or any questions that come up. I know I'm not the greatest teacher of all time, but hopefully I've been able to explain it in a clear enough way that it kind of makes sense. And if it doesn't make sense, you can just copy and paste the code and you can do whatever you want with it. So that's it for this video, guys. Thank you for watching. And if you have any questions, like I said, reach out to me on Twitter. Be sure to hit the like button as well as subscribe to the channel. It would really mean a lot. And I will catch you in the next video. Thanks again.